So in this section, we are going to learn about the complex types of data. So what you already learned until now is only the basic types of data. And now let's see how we can deal with the complex type of data. Complex, okay, it means the data might be in the multi-dimensional. So we have the multi-dimensional analysis. And there should be a description, or we call it the descriptive mining of complex data objects. Some other complex types of data might be about the spatial database. So spatial, it means it is related to Earth. And we can also have the multimedia database. So the multimedia database, it can be about video, or it can be about the image, or it can be about audio. Okay. Now, let's see if we have complex data objects by looking at the data structure. So we can make a generalization of structured data. There are two kinds of attributes. The first is the set value attribute, and the other is list value or the sequence value attribute. So what is the set value attribute? The set value attribute means this is the generalization of its value in the set into its corresponding higher level concept. The keyword is this one. Correspond to higher level. Higher level. So it is the next level or the higher concept. For example, if I have the hobby is tennis, hockey, chess, then what is the higher level? The higher level is sports. Violin, okay, because we have only one, it is music. But let's say if you have piano, let's say if you have another kind of instrument like guitar, okay, or you have another instrument, for example, drum, then we can also have the higher level of violin, piano, guitar, and drum into music. So it is the derivation of general behavior of the set, such as the number of elements in the set, the types or value range in the set, or the weighted area, the weighted average for the numerical data. So if you see this one, sports, okay, there are three kinds of sports. Music, there is only one of music. Video games, so there's only one of the video games. Let's say if you have season, then it means we can have the season like winter, summer, okay, spring, and then fall. So it means in one season there will be 4 categories. So one category, you can try to get the data only on winter. You can get the data only on summer. You can get the data only on spring. You can get the data only on fall. We have a list value or a sequence value attribute. It is the same as set value attributes. Same as the set value attribute. But except that the order, meaning by order means sunso. So the order of the elements in the sequence should be observed in the generalization. Okay. For example, I do not care which one is the first, tennis, hockey, or chess. Okay. 순서 없이 이거 다 운동. So without any order, I know that it is belong to sports. But what about this one? The activity. So I want to cook ramen. So those activities are, those activities belong to the higher level of activity, which is cook ramen. But if you do not apply the order, you cannot say it is cooked ramen. For example, first you need to boil the water, and then you need to put the noodle, and then you need to put the sauce, and then you can serve the noodle. Okay, so it should be in the sequence: number 1, number 2, number 3, number 4. But if you do not apply the order, for example, this is number 1, this is number 2, this is number 3, this is number 4, then it is not cooked ramen. It's different. When we have the data, like the spatial data and the multimedia data, the spatial data means something related with the geography. So it is related with the geographic point, like if we have the cluster regions. Cluster regions means, if you know in Korea, you have the clusters such as, okay, this is the Jeju area, and then this is the Hunnam area, this is the Chungcheon area, okay, this is the Gangwon area, and then this is the metropolitan area. Okay, so we call this is the cluster, and you can analyze more on the cluster regions. For example, okay, in the metropolitan area there are many business, residential, and industry. In this area there are a lot of agricultures and so on. So it requires the merge of a set of geographic areas by the spatial operations. So the spatial operation means I know that there will be a separator between the region. Okay. So it's like the separator of the region. Image data. So you can extract by aggregation and or approximation. So for example, I want to know this orange. If the color of this orange is yellow, then I can say it is ripe. Ripe. What is ripe? Yeah, it means it is ready to eat. Okay. But if the color is still green, then you need to wait for some time. Then you need to know the size. What is the size of the orange? You need to know the color. You need to know the shape. You need to know the texture, orientation, and the relative position, and the structures of the content object or the region of the images. So if you can detect this one, okay, this is the object, and then we know the color, we can know the location, we can know the structure, and etc. Then, okay, this is still not right. Okay, we need to wait. But this one is already right. Then we can take it. If it is related to the music data, it means we can summarize by the melody. What is the melody? The melody means something about the how the singer can sing the song. And then in the melody there will be chords, whether it is C, A minor, D minor, G7, and etc. And then there will be drums, so it depends on the beat. And there might be some other instruments. So the other instruments can be related to the trumpet or saxophone or guitar and etc. So if you can analyze those, okay, then we can know what kind of rhythm of this song. So we can summarize the style. Okay, this is ballad song, or this is a disco song. This is a kind of jazz. This is a classical song, and etc. So you can make the AI, the artificial intelligence, once you extract those data. In the spatial data warehousing, we need to understand how to make the spatial data warehouse. You still remember what is the aspect of the data warehouse? Integrated, subject oriented, time variant, and non-formal. So you can look at the aspect of this data warehouse in the material before the meeting set. And we can also integrate the data. The spatial data integration, it is a big issue. If you know already about the structure, you can use the line features or you can use the raster features. The line features, it is just separating the area. If you use the raster line features, then you make a grid. After you make a grid, you will separate the area with another color. So you can use the structure specific format. Structure specific format means whether you are using raster, this one is raster, or you use the factor base. So this is also another kind of factor. Or if you are learning the database, you will have the OO. You know OO? OO means object oriented. So in the object oriented, you can define, for example, I want to know whether it is a mountain or it is a river or if it is a forest. Okay. So there will be some characteristics. Mountain, okay, then we can see something high. River, we can see something with the blue color in the middle of the green. Forest, so there will be a lot of green because there will be a lot of trees and so on. So it is based on the object. Or if we use the relational model, so the database usually it is in the relational model. Different storage and indexing. So if you store the data like this one, so you can save the data in the relational database format. And how you can use the index is different. There's also another issue with the vendor. If you use the ArcGIS, the vendor will be ESRI. So for example, this one. This is based on the map info tool. So the area is the same, but the representation is different. This is using the map info, this is using the ArcGIS. So different software, they will show different representation about the same area because they may have different format. And yeah, we also learn about the data cube. Data cube means we have the multi-dimensional spatial database. So both dimension and measures may contain spatial components. Okay, like for example, if we are dealing with the spatial data warehouse, we can look into the dimension modeling and the measures. Okay, what are they? If the dimensional modeling, it is about the non-spatial, so we can just generalize the degree 25 until 30, it is hard. If it is about spatial to non-spatial, let's say I would like to apply the word Unjung Dong, okay, it can be generalized to the region West Pangyu or South Pangyu. If you live in Pangyu, you will know there are some dong over there. The word is Unjung Dong. Or if you want to make the spatial to spatial, so the region Bundang, it can be generalized to a bigger religion, which is Gyeonggi. This is about the dimension. You can look more into the measures. The measures, yeah, if you still remember in the data warehouse, you can look at 3 different measures. For example, the distributive, or the algebraic, or the holistics. Distributive means you can count how many. You can do the summation. For the algebraic, you can check the average. For the holistics, you can make the median, and you can also measure the rank. For the spatial measures, yeah, we can have the collection of the spatial pointers. For example, I would like to point all regions with 25 until 30 degrees in July. So let's say like this one. This is the weather pattern analysis in Seoul. So you can make the input, okay, in the data warehouse. So I have the input 23 automatic weather station in Seoul metropolitan area. So there are some kind of station, okay, in Seoul, and there are 23. We call it the AWS. It is the automatic weather station. So they will detect every minute or every hour what is the temperature, what is the humidity, what is the fine dust, misemonji, and so on. So they detect all the things into the database, and they record the daily data for the temperature, precipitation, wind velocity, and moisture. And they apply the concept hierarchies for all attributes. The output will be a map. So this will be the output. So when you get the data, so the tools or the spatial data warehouse will show this output. And there might be some goals. For example, the interactive analysis. I can do drill down, slice, dice, pivot, roll up. You still remember this? This is the function in the data warehouse. So this is the Seoul city. But I want to look more on the Gangnam. Okay, then I can drill down. So how can I give the fast response time? And how can we minimize the storage space use? So the challenge is a merged region may contain hundreds of primitive regions. So for example, the region, you cannot make rectangle like this, but the region will be something in polygon. So this is a challenge when we deal with the spatial data. Okay, then let me stop here. Okay, I will continue again tomorrow. Any questions? Then thank you very much for attending the course. See you tomorrow. See you.